In this video note, we're going to think about programs that require more than one class. We've already seen from the house project that we can get objects from different classes to collaborate together to create an application. Here, a picture made up of squares, circles and triangles, although we didn't look in detail at how that was achieved. Now that we've been introduced to the basic source code elements of Java classes, we're in a position to understand how objects can collaborate to accomplish sophisticated tasks. The example we're going to use is clock display. This implements the basic elements of how to display a digital time. There are actually two versions of this project that come with the book. One contains a GUI to display the current time on the clock and how it changes every tick. We can update the time manually via the step button, or we can run it continually via the start button, though it clearly doesn't count up in minutes in this version. We'll keep things simple and use the version of the project without a GUI. There are two classes, clock display and number display. Clock display and number display are ordinary classes, and we can create instances on the object bench as usual. If I create a number display object, I have to supply an integer rollover limit to the constructor. I'll give it a rollover value of 5 and see what that actually means. If we bring up an inspector, we can see that the rollover limit has been stored in a limit field. There's also a second field called value. The object has methods, so I can interact with the object to see how its state changes. Calling increment, the value field is increased by 1 each time. If we keep on calling increment, we see that instead of going from 4 to 5, the value rolls over to 0. That's the effect of the limit. It prevents the value field being greater than or equal to the limit. This is exactly the behavior that will be used by the clock to manage counts of hours and minutes. Looking at the source of number display illustrates that it's similar in content, if not in function, to Ticket Machine. It has a descriptive comment, a standard class header, an opening curly bracket, and some fields. This is the standard structure of the opening of a class that you should be used to seeing by now. The fields follow the required order of a visibility, a type, a name, and a semicolon. Scrolling down, we can see that it has a constructor with the same name as the class. The constructor takes a single parameter, the rollover limit that has to be passed in when a number display object is created. The rollover limit is stored into the limit field. For our clock, we'll want two number display objects, one to count the minutes and one to count the hours. But we don't want to have to create these number display objects by hand for each clock. Instead, we want the clock to do that for us. That's exactly the purpose of the clock display class. In addition, a clock display object will coordinate the link between the two number display objects as each minute counter rolls over to the next hour. It's the clock display class that we will spend the rest of this video note considering. Before we look at its source code, let's look at the external operation of a clock display. We'll create one using the constructor that doesn't take any arguments, and then bring up an inspector. We can see that the inspector shows that the clock display already stores a string representing the current time, midnight. If we call the timeTick method on the clock display, we can see that the display string is updated to count consecutive minutes. We can also call the setTime method to change the clock to a different time. This will allow us to observe what happens when the minute value rolls over. We set the time to be 7:58 and call timeTick. We observe that the clock does indeed correctly register the change to the next hour. We can also see that a call to getTime returns the value of the display string. Now we clear the object bench before taking a look at the source code of clock display. Once again, we see exactly the same style, structure and layout of a class. The familiarity of the style means that we don't actually have to look in great detail at each individual line. This will often save us time and effort when investigating new classes. The main point we want to emphasize here is the fact that the fields are not simple integer types as we've been used to seeing. They are class types. It's the class name number display that stands in the position we expect to find a type name. Two of the fields are used to refer to the two number display objects that will maintain the current time components of a clock. The third will refer to a string object that holds the current time display. It's important to appreciate that the field variables are not of themselves the objects. We don't get objects just by defining a variable of class type. Creating the actual objects will be a separate step, which will be similar to what we demonstrated on the object bench. However, this time it's the clock display objects that will create them, and we'll find the code for that in the constructor. In the constructor, we can see exactly how the number display objects are created. One is created with a rollover limit of 24 for the hours, and the other with a limit of 60 for the minutes. These values fit what we have already seen of the way in which number display objects use their rollover limit. A clock never displays 60 for minutes or 24 for hours. It stops at either 59 or 23 before rolling round to 0. In a later video note for this chapter, we will actually look at the object creation process in more detail, how the clock display's fields are initialized with the required object references. There is clearly a very close association between the clock display class and the number display class. A clock display object is completely reliant on number display objects for keeping track of the current time, because the clock display object does not have any integer fields of its own for counting minutes and hours. Something of this close association is illustrated in the class diagram. The arrow indicates an association between clock display and number display. Notice too that the arrow is directional, going from clock display to number display. We can think of the arrow as indicating awareness of one class by another. Clock display objects know about and use number display objects, but number display objects know nothing about clock display objects. Number display objects just passively respond to calls of their methods. In summary, we've shown that the source code of both clock display and number display has been written to the same pattern as we saw in the ticket machine class: fields, constructors, and methods. We've also seen that a clock display object makes use of two number display objects to do its job. When each clock display object is created, it takes responsibility for creating the two number display objects it needs. This leads to a close association between the two classes, which is reflected in the class diagram.